Okay, let's jump in. Today we're doing a deep dive on a really interesting piece of tech, the DVIGear DVI-2312-AOC. It's their HyperLight active optical cable.
Right. And the big question here is, why are we still talking about DVI? It feels like a legacy standard.
Exactly. But this cable, it hints at way. We're talking about pushing high-res video over, frankly, massive distances securely.
And that's the key. In certain mission-critical places, think control rooms or secure government facilities, DVI is still trusted. The challenge for you has always been distance.
So how far are we talking?
We're talking 328 feet. That's 100 meters for a single-link DVI signal. It can handle up to 4.95 gigabits per second total.
Wow. That's enough for, what, 1920 by 1200?
Yeah, 1920 by 1200, even 2048 by 1080.
Yeah.
But 100 meters of pure digital video, that's a huge engineering feat.
It is. And the performance isn't even the whole story. It's how they do it. This isn't just a long copper wire, is it?
No, not at all. That's where the smart design comes in. It's a hybrid cable. So you've got 4 strands of POF that's polyphenonated optical fiber, and then 6 regular copper wires.
Okay, so a mix. What does what?
This is the crucial part. The high-speed video data travels only on the optical fibers. The copper is just for lower speed control signals and critically for power.
Ah, so you're separating the data from any potential interference.
Precisely.
Yeah.
By putting the video on optical fiber, you make it completely immune to environmental noise. We're talking a very, very low RFI and EMI profile.
Which is why it's a fit for those sensitive applications you mentioned.
It's perfect for them. The signal is clean, and it's also much harder to intercept. It adds a layer of security that you just don't get with a standard copper cable.
Okay, that makes sense for reliability. But you mentioned power. This is an active cable. 100 meters is a long way to send power.
It is, and that's the other really amazing part of the design. It's incredibly efficient.
How efficient?
It draws less than 0.3 watts, max, and it pulls all of that power directly from the DVI source device.
No way. So there's no external power adapter you have to plug in somewhere in the middle of the run?
None. No power brick. For an installer putting this in a ceiling or a conduit, that's a massive win.
That's a huge logistical advantage. But, efficiency doesn't matter if the cable is a nightmare to physically run. I'm picturing something thick and rigid.
And that's the aha moment for anyone who's ever done this work. The cable is actually plenum rated, so it's tough, but it's also lightweight and very, very flexible.
How flexible?
Get this, it has a minimum bend radius of just 2 millimeters.
2 millimeters. That's unbelievable. You can basically fold it.
Almost. Imagine trying to pull a stiff copper cable around a tight 90-degree corner inside a wall. Now imagine doing it with this.
And they must have solved the other big installer headache, which is always the giant DVI connector itself.
They did. The 2 DVI docking connectors are actually removable.
Oh, that's smart.
Yeah, you just detach them, and the cross-section of the cable end shrinks to just about 14 by 14 millimeters. So now you can pull it through really narrow conduits without a fight.
That's a game changer. It saves so much time and frustration. I see they also include fixation screws on those connectors.
Right, and removable pull covers. So it's secure while you're pulling it through, and then it locks in tight once it's in place. And just for clarity, it's DVI 1.0, supports HDCP 1.4, and you can use it with HDMI gear if you have an adapter.
So when you put it all together, what does this mean for you, the user?
It means you're getting a complete system upgrade for what might be older but still reliable infrastructure.
Yeah.
It's durable, it's secure from interference, and it solves the biggest physical challenges of long-distance video runs. It basically proves you can future-proof the DVI standard with this kind of hybrid tech.
It really does. The engineering here is just a fantastic balancing act, maintaining nearly 5 gigs of data performance over 100 meters, all while sipping power from the source. It's incredible.
It is a really elegant solution.
So the thought I want to leave you with is this. As you're thinking about your next setup, consider what other connectivity problems could be solved with the same approach. This blend of using optical fiber for pure, high-speed data and using copper just for power and control. Where else could that be the perfect answer? Something to think about.